Okay, class, sorry to be out again. Today we're going to talk about the law of sines and the law of cosines. So the first thing you need to do when you're dealing with the law of sines and the law of cosines is to be aware of some rules about triangles that you may have forgotten. First, the sum of the interior angles of a triangle add up to be 180 degrees. Second, the biggest side is always opposite the biggest angle in a triangle. So if you just have any old triangle, it doesn't matter if it's acute, obtuse, or right. And you have, let's say, these measures. The biggest angle in this picture would have to be angle A. And in turn, the littlest angle would be angle C. Obviously, my picture is not really drawn to scale. And then the last one, to solve a triangle, means that you find all of the sides and all of the angles that are contained within that triangle. We review the rules of triangles because the law of sines and the law of cosines both deal with triangles. And even though they involve trigonometry, they can actually be applied to any triangle, whether it be acute, obtuse, or right. Before, trigonometry was only allowed to be used with right triangles. And we've expanded that into a different realm, if you will. So the first one is the law of cosines. And the law of cosines, if you notice, kind of looks like the Pythagorean theorem. It comes from the Pythagorean theorem. We aren't going to go into the full proof right now. But the law of cosines deals with triangle ABC, which I have drawn for you right here. Notice in triangle ABC, the capital letters represent the vertices of the angle, and the lowercase letters represent the sides. And angle C is opposite of side C, and angle B is opposite side B, and angle A is opposite side A. And you can kind of assume this rule for every single triangle, unless you're specifically drawing a picture that doesn't match this situation. On your homework assignment, a lot of the triangles are just give you like capital A and lowercase a and other letters, and then you just have to figure out and draw the picture yourself. So this is the law of cosines. It's pretty important that it makes its way into your notes. C squared equals a squared plus b squared minus 2ab cosine c. And it looks very confusing, but it's actually not really that bad. It actually also does not matter what side is A, what side is B, and what side is C. The key thing is, whenever you're doing the law of cosines, that whatever angle you're evaluating the cosine of, the c squared is on the side across from that. So like here's your C. Whatever side is across from side C has to be the side by itself. So you could rearrange this and say a squared equals b squared plus c squared minus 2bc cosine of A if you wanted. It doesn't really matter. The key thing to pay attention to is whatever angle you're working with, this side has to be opposite it. And basically, these two make up the other two sides. When you look at a problem that actually involves using the law of cosines, you kind of notice that you have a side and then the angle in between, and then here's another side on the end. So if you were to try to find angle A here, you would set up the equation a squared equals 14 squared plus 12 squared minus 2 times 14 times 12 times the cosine of 39.4. And then from here on out, you can use a calculator. And in fact, all of these law of sines and law of cosine problems are going to be dealing with calculator operations. So make sure you have a calculator with you, and make sure your calculator is in degree mode. All of your angles are going to be given to you in degrees when you're dealing with triangles like this. And you can punch it in just exactly how you see it. 14 squared plus 12 squared minus 2 times 14 times 12 times the cosine of 39.4. And you get the answer of a squared equals 80.36. And then you just have to square root both sides. Now, when you're in this situation, remember, since you're dealing with the sides of a triangle, technically, yes, when you solve by square rooting, you're supposed to include plus or minus. But because you have a side measure, you actually don't need to use the plus or minus because the side can't measure a negative number. So this is one way you can use the law of cosines to find the opposite side. You can also use the law of cosines to find an angle. So if you have three sides, you can use the law of cosines to figure out, in this case, what we've labeled x. So again, the key thing is to pay attention to this side opposite the x has to be isolated by itself. So it has to be 19 squared, and then the other two numbers make up the 14 and the 8. Minus 2 times 14 times 8 times the cosine, this time of x. So I have 19 squared, which is 361, and then 14 squared, which is 196, and then 64 is 8 squared, and then 2 times 14 times 8 is 224. Oops, not equals. Multiplied by the cosine of x. And so again, you solve this a lot like the trigonometric equations we were working on before. You need to move both the 196 and the 64 to the other side of the equation. So you get 101. And then divide both sides by 224, negative 224. I know when we were working on solving trig equations, I always told you not really to worry about the negatives and to focus on what the angle measures. Here, you just want to punch it in your calculator. Remember, to do this in your calculator, you have to do the inverse cosine. And I would actually wait till the very last minute to punch it in your calculator. So that way your answer is exact as possible. If you end up being a few decimal places off from me, it's not the end of the world, but sometimes it helps. If your answer is as close to the answer key as possible. So again, remember, for this you use the second button, second cosine, to find the angle measure. And that is the law of cosines. The law of cosines is very popular to use when you have a situation like this, where you're trying to find a side, and you have two sides with an angle in between, or when you have three sides. Now, let's talk about the law of sines. The law of sines is the easier of the two rules to remember because it's just a proportion, but it has a couple tricks and goofy things involved with it, which makes life a little complicated. So when you're doing the law of sines, notice here there are three parts of the equation. You actually only need two of them to be able to do the law of sines. So like if you had angle B and side B and side C and angle A, or angle C, you could use the law of sines this way. Or you could use like angle A and side A and the sine of angle C and side C. It doesn't really matter as long as you have opposites. That's what this is working with. It's working with the fact that you have opposite pairs. So you'll notice on this example, it says solve. So you want to, when you solve, you find everything. You find all the missing sides and all the missing angles. So first, finding this missing angle is really, really easy because you just have to take away 112 and 29 from 180 because the sum of the angles of all triangles add up to be 180. So this angle N is 39 degrees. And now you have opposites. So it doesn't matter which side you find first. Let's find N first. So if I wanted to find side N, I would do the sine of 39 over N equals, and then pick a pair. You wouldn't pick 112 and M because that creates another variable, which makes life more complicated. You would say the sine of 29 over 22. And then some cross multiplying happens. Whenever you have a fraction equal to a fraction, you always cross multiply. And again, just like before, I would wait till the very last possible moment to punch things in your calculator. So you'll punch in the 22 times the sine of 39. Make sure when you punch this in your calculator, if you have a calculator that automatically opens parentheses, that you close them before you type in the division of the sine of 29. So I got in to equal 28.56 when I round to 2 decimal places. And then this process is exactly the same to find side m. If I wanted, now that I have sine n, I could use the law of cosines to find m, but the law of sines is a lot simpler. So this time you would say the sine of 112 over letter m this time. And I usually stick with the information that I'm given. I like to avoid using extra decimals if I can avoid it. Sometimes it is unavoidable. So then you cross multiply again, 22 times the sine of 112 equals m times the sine of 29. And then again, divide both sides by the sine of 29. So 22 times the sine of 112 over the sine of 29 equals m. And so I get m equal to 42.07. And it is kind of nice when you solve a triangle. You can kind of check yourself a little bit and make sure that your biggest side is opposite your biggest angle. So 42 is across from 112, and then 28 is across from 39, and the littlest side is opposite the littlest angle. So that's always a nice way to check yourself. If it doesn't end up that way, then something horrible has happened. Now, the thing to really be aware of and careful of is when you're using the law of sines and you're finding an angle, sometimes things get a little goofy, because if you think about solving for a hot minute and you have your all students take calculus, whenever you're finding an angle measure, your sine is positive here and here. Now, this isn't an issue when you use the law of cosines, because the other place where the cosine is positive is here, and we don't have negative angle measures inside triangles. So this is why this is no issue for the law of cosines. But for the law of sines, since both potential answers that you have for sine are less than 180, sometimes you actually end up having two triangles that would work for your situation. And we'll go through an example that actually has that here in a minute. But always be aware of that. Whenever you have to find an angle, that's the key thing. If you're finding a side, this doesn't matter. Whenever you're finding an angle, you have the potential for two triangles. So let's work through it. Here, I want to find side y. Unfortunately, I don't have opposites. I also don't have enough information to use the law of cosines, because 11 would have to be like over here to do the law of cosines. Because again, I still need opposites. I could potentially try to use the law of cosines, but it would involve a lot of creative factoring. So we kind of have to do a roundabout way of getting y. I can't find side y right away, but I do have an opposite with 8 and z. So if I find z, then I can use z to help me find y. So I'll do the sine of z equals the sine of the opposites here, which would be 64 over 11. And then this time I'm not really going to bother cross multiplying. I'm just going to multiply both sides by 8. That gets rid of the fraction. So the sine of z equals 8 times the sine of 64 over 11. And then, again, to find an angle, you do the inverse sine. So, again, punch this in your calculator exactly how you see it. Inverse sine, so second sine, 8 times the sine of 64. It does seem a little weird to have a sine inside of a sine, but it's normal. It happens often. So one potential answer for angle Z is 40.82. Now, because whenever I'm solving a sine, and my sines are positive in the first and second quadrant, I do have another potential answer of 180 minus 40.82, as if 40.82 was the reference angle right here. Which is 139.18. Well, how do you know if you actually have a second triangle? Well, the little angle is almost always automatically going to work. Your acute angle, 40.82. But if I try to make this angle be 139.82, or 18. If I add these two up, 139.18 plus 64, well, that's 203.18. 203.18 is bigger than 180 degrees. So 139 doesn't work because that plus the angle I was given is bigger than 180. So this triangle only has one option for angle Z. Now that I found angle Z, I can take away 64 and 40.82 from 180, 64, to get 75.18. And then I would continue on with my process. I can do the law of sines to figure this out. So I have the sine of 75.18 over 8 equals the sine of 40.82 over y. And actually, I kind of just broke my rule that I like to use. I like to use the numbers that they give me instead of the numbers I find. So for this first fraction, I'm going to switch it back to 64 over 11. And I should get the same answer. So cross multiply at this point. And then divide by the sine of 64. We'll pop that in our calculator. And I get 7.83 for y. So now let's look at this next one. This time I didn't give you a picture. So let's draw it. Let's draw your own picture. We got ABC. It says angle A is 30 degrees. Side A, so that means the side opposite angle A, is 4. And then side B is 6. And it says solve. So in this case, my only option is to use the law of sines. So we have opposites here with A and 4. So the sine of 30 over 4 equals, and then we have opposites here, so the sine of B over 6. This time I'll just multiply both sides by 6. And then I'll do the inverse sine. And now it's just time for me to punch it into my calculator. The inverse side of 6 times the sine of 30, which, by the way, the sine of 30 is a half, so you can actually do this without a calculator if you want, or at least part of it without a calculator. So this angle is 48.59 degrees, or, again, because whenever I do an inverse sine, since both angles are smaller than 180, or both positive values are smaller than 180, I need to be aware of the fact that I could have a second triangle. So now, this first angle measure of 48.59 for B is almost always going to work, but let's think about 131. So if I take 131.41 and I add on 30, which was my original angle, I get 161.41, which is less than 180, which means that I have a second triangle that I need to consider. So I'm going to draw this triangle again, ABC. Keep my given information, that does not change. So A is 30, the side opposite A is 4, and the side opposite B is 6, that stays the same. But instead of angle B being 48.59, it has to be 31.41. And then I solve both triangles independently, because these are two totally different possible answers. So over here, for my first triangle, triangle 1, I got to figure out side C by taking 30 and 48.59 away from 180. So this angle is 101.41. And now I can do the law of sines again, or at this point I could use the law of cosines if I wanted, to find side C1, if you want to call it that. So I would say the sine of 101.4 over side C1 for triangle 1 equals the sine of 30 over 4. And this is when I like to do my cross multiplying. So the sine of 30 times C1 equals 4 times the sine of 101.41. Then divide by the sine of 30. And punch it in your calculator. 0.41 divided by the sine of 30. So my first option for side C is 7.84. That's one option. And then for my second option for C1, again, I got to take 131.41 and 30 away from 180 degrees. And this time this angle ends up being very small at 18.59. And then I have to do the same thing again. This time we'll call it C2 because it's my second option for side C. So it would be the sine of 18.59 over C2 equals, and again, I'm going to stick with the sine of 30 over 4. I like to stay consistent. Cross multiply. So C2 times the sine of 30 equals 4 times the sine of 18.59. And then divide by the sine of 30 again. And I get a very small side measure at 2.55. I know this seems like a lot, but at the same time, it's really not that bad. You just have to do the law of sines a whole bunch of times. And just as a side note, when you're doing the law of sines and you're finding an angle, you could have one triangle, which is great. You can have two triangles, which is a little bit of extra work, or you can actually have no triangle. So if you set up the law of sines and you do your cross multiplying and your inverse and all that fun stuff, and then you end up with an error message in your calculator, that means that you have no triangles that fit the situation. So you would just write no solution. And then here are a few tips. When you're doing these, first, use the law of cosines whenever possible. Whenever you're doing the law of cosines, you won't have two triangles. So it's going to make life easier on you. But if you have to find an angle and you have options, you always want to try to find the biggest angle first. That is often going to avoid a two triangle situation and will save you a lot of time and energy. And that's all we have for